bad in general.
Hold on.
Who are you looking?
I'm looking for somebody that cares.
Oh, I can.
I can, Cassidy.
See, Hannah cares. I don't.
Hold on.
April Fools.
Nobody cares about that either.
He's just.
Actually,
I think you should be.
I have many people.
Okay. Let's graph 2 to the x power.
Negative.
No,
Wait, what?
we're going to graph
Oh.
2 to the x power.
Wrong one.
Okay? 2 to the x power.
Wait, but on the bottom one it says -2.
Don't worry, Hannah. I fell for it too.
Then we're going to compare.
Wait, I know one of the points. Ask me what one of the points are.
Okay, give me a point.
0, 1.
0, 1. Plug in a 0. 2 to the 0 power is
1.
1. 2 to the first power.
2.
2. 2 to the second power.
4.
4. 2 to the third power.
8.
8. 2 to the fourth power.
Can't grab it.
16. 2 to the -1 power.
-2.
2. Wait,
I don't know.
2 to the -2.
Undefined. Just kidding.
2 to the -1 power.
Oh, 1/2, 1/2.
Okay,
Boom.
remember, a
Oh.
negative exponent is reciprocal. So that would be 1/2. 2 to the -2 power would be
1, -1. Wait, 1. 0?
the
It's
negative is the
1/4.
reciprocal, it's 1/4.
1/4.
Okay,
Oh, it's a.
So. what's an asymptote? It's a exponential. Where's the asymptote?
It keeps getting smaller.
The
So it's not
asymptote is 0.
The x-axis is an asymptote, right?
Oh, yeah.
Okay, so to graph y equals 2 to the x power, it's really, really, really close here. And it's getting higher and higher and higher. And then the exponential piece takes off, and we take off like that. So that is the graph of y equals 2 to the x power. We're now going to graph, by looking at that, we're going to graph this function with an eraser.
Still looks like. Oh, I was about to say, I don't think you can do that.
I just like making things hard to see. What's that negative sign going to do to the function?
It's going to turn it around.
Flip it across the
Y-axis.
x-axis. Guys, we're doing the exact same things we've done before with transformations, okay? The function was 2 to the x power. I'm taking the opposite of that function. So this negative sign right here is a reflection across the x-axis.
Wait, so how would it get reflected over the y-axis then? Like, what would you have to change from the
What is that
original equation?
It'd be a negative x. 2 to the negative x power.
Okay.
Is it going to be?
Okay, So all of these points are going to reflect.
Oh, it's just the exact same.
And I can't see what's
You
going
were
on over
doing
there.
it so good.
I know, it's hard to see over there. Okay, so there it is. Now I'm talking about the red graph now. I'm talking about y equals -2 to the x power. What is the domain of this function I just graphed?
All real numbers.
Hasn't changed, all real numbers. What is my range now?
0.
No, because it never touches 0.
Never touches 0.
Negative infinity to
Negative infinity to
0.
0, right? The
Wait,
blue one, domain is all real. The blue one, the domain is 0 to infinity. No brackets, right? Parentheses because it can't touch.
just like
So, no, can't equal 0. So when we reflect it across the x-axis, it now goes from negative infinity to 0, not including 0.
confusing. What's confusing about it? The domain and range. I don't get it.
Okay?
Wait.
I have a lot of it. Quit making fun of me.
Wait.
There it is again. I can't get away from it.
Sorry, my head is taking so long to think today. So
Where did the 0 come from?
okay. So it's for the blue one, right?
No, I've done the red one. That's
No,
why
I was
it's
just
in red.
kidding. It's for the red one.
Okay.
Yeah, but where did the 0 come from?
So
Because
Zero.
it never gets there. It never gets to the range is the y value, right?
The range is going up B.
So it's stuck. The x axis is an asymptote. So the red graph is stuck down there. It gets closer and closer and closer to the x axis, but it'll never touch it. That's where the 0 came from.
So is it always a 0? Always gonna be?
Hold up,
Is
I'm
the range
confused. It's
always
Not yet.
backwards.
What?
It's backwards.
No, 'cause-
Okay, let's do another one.
Wait, but it's
don't think about it too hard. You just gotta let it be.
backwards.
You just gotta let
Because
it
it can't equal 0.
let it vibe.
Okay.
Wait, but it goes from okay.
All right.
Let it go.
We're gonna start with graphing 2 to the x power.
We just did that.
Okay. So we're at a half here. We're at 1. We're at 2. We're at 4. We're at 8.
And a B.
Whoa.
Goodness gracious.
Okay. So there's the parent. It's a parent function of exponential. We're going to graph this graph. 2 to the x plus 3 power. What's the transformation?
+3.
No.
Diego, did you say something? Or
I was
Mason
gonna say I was gonna move up 3, but no.
Do it.
Go straight.
Left 3.
Oh, what the heck?
So it's like what's in parentheses.
Remember I said if something's in some kind of a grouping, it's gonna be backwards from what it looks like? Let's think about this. X plus 3 is kind of trapped. X plus 3 is a group. It's an exponent. Okay? We're changing the input value. So every point on that blue graph needs to be shifted 3 units to the left. Huh?
Oh, wait, never mind.
3-1.
The ones in blue need to be shifted 3 to the left to give me the red graph. So that point is here.
Up to the left.
This point is here. This point, 1, 2, 3. 1, 2, 3. I skipped one. That one up there, 1, 2, 3. Okay. So we'll draw this guy in. Right here. Okay. Looking at the red graph. What's the domain?
And
All
would the asymptotes be, would the red line eventually go on to the blue line since the asymptote is 0?
Can't. The red line will always be above the blue, and neither one of them will ever get to 0.
0 infinity.
But if, then it wouldn't be 0, wouldn't be the asymptote.
It
Would
is
0
too.
still be the asymptote?
It's still the asymptote.
Of
Wait,
the red
wait.
line,
Yeah, so both of them,
Would the red line touch
but
the
it just
blue line?
doesn't get as close as the blue line?
correct.
I hate this.
Wait, but the blue line's not the red line's asymptote?
No, the asymptote's still the x-axis.
So will the domain always be negative infinity?
Will the domain always be negative infinity to infinity for the parent function? Yeah, it's going to be.
0 infinity.
So the range of the red function and the range of the blue function are exactly the same. The red function and the blue function will never touch. The red function and the blue function will never touch 0 either.
So.
So wait, do they
Wait.
touch each other?
Nope, never. Can't,
They're siblings.
because the red one's always gonna be higher than the blue one.
It's just wrong if
Wouldn't
they
the
touch
blue
each
one be its asymptote?
No,
Honey.
no 0 is.
If they
Sorry,
never
yeah,
touch,
about
then wouldn't it be its
And,
asymptote?
nope.
So
they're like
parallel lines.
No. Please, calm down. Parallel lines are always the same distance apart. The red and blue graph are never, they're not the same distance.
But then why wouldn't it be?
I was just kidding.
Okay,
Uh-oh. Don't feel bad.
do you have a question back there?
Did he watch these?
Nothing?
Yes.
Okay,
No.
You
I'm
might-
recording.
yeah.
Knock it off.
Oh goodness.
Y equals 2 to the x. That graph's gonna be the same. Base is still 2. We've got some shifts going on. What do we see? Okay.
But would the -1 shift it down?
Yeah. So I will take every one of those points that I plotted. I will move those points 2 to the right, down 1. Okay. So this point at 3, 8, 2 to the right, down 1. This point at 2, 4, 2 to the right, down 1. At 1, 2, 2 to the right, down 1. 0, 1, 2 to the right, down 1. -1, 1/2, 2 to the right, down 1.
I thought I could never touch.
That's
That's
negative
it's a
one,
different
yeah.
asymptote.
Okay. What did the graph do?
Shift down.
It shifted right 2 and down 1. Well, what happened when it shifted down 1?
It changed the asymptote.
The asymptote changed. Okay? So, what's my domain?
All real numbers.
It hasn't changed. What is my range now?
-1 infinity.
I usually put the smallest number first,
That
like,
is.
like you said.
Oh, I was like, what?
Uh-huh. Trying to tell me I'm wrong.
Well, it's so natural and common that I get confused when you get it right. I'm sorry.
Oh, so funny.
Okay.
It's actually hilarious.
So the horizontal asymptote moved down 1 unit. Domain stayed the same. Questions? Because the graph of f of x equals a to the x is a 1-to-1 function, if we had 2 expressions, a to the x sub 1 equals a to the x sub 2, notice those a's are the same, right? If a to the x sub 1 is equal to a to the x sub 2, the only way that could happen is if x sub 1 and x sub 2 are equal. Okay? So when we're solving exponential equations, what we want to try to do is rewrite the equation with both sides using the exact same base. If the bases are the same, then we set the exponents equal to each other, and we actually ignore the base. This property is used to solve an exponential equation, which is an equation with a variable in the exponent. Okay. So here's the problem. The first problem. I have 1/3 to the x power is equal to 81. This function, this equation is exponential because the variable is in the exponent. I need to somehow write this problem using the exact same base on both sides. What base can we use for 1/3 and for 81?
9.
No.
Wait, I don't actually know.
3. No.
3.
Darn it.
Oh my gosh.
Anna's smart.
Okay. We don't want to use 9 because 9 is 3 squared. Okay? And as you're doing problems like this, that's the kind of stuff you want to think about, you know. I would never want to use a base of 125 because 125 is 5 cubed. I would never want to use a base of 27 because 27 is 3 cubed. I wouldn't want to use 16 because 16 is 2 to the 4th power.
Why?
So because I can get a smaller base out of it,
Oh,
okay? I wouldn't want to use 9 because 9 is 3 squared. You want to use the smallest base possible, okay? So, 81. 81 is 3 to what power?
let's go with 20. Just go.
27.
3 to the 27th power. Yeah, no, 3 to the 4th power.
Oh wait.
Oh,
wait, I
four is
thought
four.
7.
3 times 3 is
No.
9. 3 times
Wait,
3 is
27 times 3
9.
is
9. 9 times 9 is, there you go. 3 to the 4th power is 81. Okay.
I was thinking it would be higher.
How would I write 1/3? I'll put this X out here.
3.
3 to what power is 1/3?
-1.
-1. So 3 to the -1 is the same thing as 1/3. So I have replaced 1/3 with 3 to the -1 power. Okay? What do you do when you raise a power to a power? You multiply them. So 3 to the -1 to the x would be the same thing as 3 to the -x is 3 to the 4th. Now that the bases are the same, and we're going to talk about why this works later on very soon, but since the bases are the same, the only way this can be true is if -x is equal to 4. So I've totally just thrown the 3's away, legally. But I don't care about -x, I want to know what x is.
Wait, why'd you throw the 3's away?
Because they're-
Because they're already
I don't
equal.
care about them,
Oh,
because they're the same.
base.
Oh, that's
okay,
wrong.
that's the base.
That's the base. Okay? So what's
So
x
x
equal
equals -4?
to? X is -4. Now, it's always best to check yourself. Okay? So to check it,
You plug in 4.
I want to know what is 1/3 to the -4th power.
81.
Is it?
I don't know.
Yes, I did the math in my head.
Yeah, you did, just like the fractions earlier.
Okay.
Yep.
Excuse me. I can't do that.
Oh wait, crackers.
How do you get the fries?
Hey, that's a slur.
Now it's over. My headache.
Wait, so x.
It is 81.
So it does check. That answer is correct. X is -4.
Good job, Anna.
Anna
Wait.
did it all in her head.
Uh-huh.
She types it on the calculator.
Nope.
Yeah.
Well, I mean,
Go up.
the negative sign means reciprocal, right?
Uh-huh.
So 1/3 to the -4th would be 3 to the 4th, and 3 to the 4th is 8.
Wait, but when I typed it in the calculator, just kidding. I typed it in wrong. And I got 1 over
Next
81.
problem. 2 to the x plus 4 is equal to 8 to the x minus 6.
That's two separate things.
Can you write 2 in a different base?
Yes. No, you can't.
I
It doesn't get any smaller.
Can you
than
write 8 as a base 2?
that. Yes.
2 to the
2 to the 3rd power. Okay, so I have 2 to the x plus 4 is equal to, I'm going to change the 8 to 2 to the 3rd, because 2 to the 3rd is 8. They're both the exact same thing. And that is raised to the x minus 6.
and then you multiply them, right?
Okay,
Making it
so my bases are now both 2. So my left exponent is x plus 4. And my right exponent is what?
2x minus 6.
no
No.
easy.
X minus 18.
3x minus
You
18.
have to multiply.
Oh, by both? You have
Okay,
to multiply by both?
Because that exponent must be multiplied together.
Okay.
3 has to be multiplied by x minus 6.
Yeah, I know half of it.
And that's just a very basic 6th or 7th grade algebra problem right there.
Okay, you're really hurting my feelings.
Not this part, but this part.
I feel like the other part's easier.
Okay.
What?
Subtract x from both sides.
Oh, and then you combine X.
Add 18 to both sides. Divide both sides by 2.
11.
Does it work? 2 to the 11 plus 4 power, that'd be 2 to the 15th power. 2 to the 15th power is like 32,768.
Dang.
How do you?
What's 8 to the
Big.
And I should just put it in the calculator.
It's a big thing,
So it's
because 8 is 2 to the 3rd, so it'd be 2 to the 15th again.
I did it!
Yeah, 2 to the 15th power is 32,768.
It works.
And then 8 to the 5th power would be 2 to the 3rd power to the 5th power, which would be 2 to the 15th power again. So that it is going to check. It does work. X is in fact 11.
What happens if it doesn't work?
It would not work. You did something
It
wrong.
fails.
It's
Does the
possible there'd be no
answer come from
solution.
How many more slides?
Hey, I think this is.
Questions on this one?
I'm scared. Oh.
Next problem is a typo. X to the 4/3 power is 81.
I think the answer needs to be on top.
Hmm.
And now you change it.
Oh, something about an index.
Well, this doesn't say exponential functions, it just says a fractional exponent. Okay, what's another way of writing x to the 4/3 power?
It's like the cubed root of x to the 4th power.
Okay,
That's my
it's
guess.
the cubed root of x. Now, I could put the 4th power in one of two places. I could put the 4 here on the inside of the radical, or I could put it on the outside. Since I'm trying to solve for x, I'm going to go ahead and put it on the outside.
It would be.
I am solving for x. I need to get x by itself. I need to make the cube root go away. I need to make the 4th power go away. First thing I would want to do is get rid of the 4th power. How do you get rid of a 4th power?
Quarter rooted.
Divide.
You take the 4th root. Exactly right.
Wait, Lonnie, you're on a roll.
I know, I'm like super smart or something.
Okay.
Hmm.
This hurts my brain to make you tired.
Taking the 4th root of something to the 4th power will cancel out those 4s. So I'm left with the cubed root of x equals, and what is the 4th root of 81?
9.
Yeah.
Oh, 3.
3.
3 is half right.
Wait, how do you do that? In the calculator.
So it'll be 6.
Or
Plus
negative.
7. Right.
3i. Just kidding.
Plus or minus 3.
Oh my goodness.
Okay,
Wait, how
you
do you?
use this ugly color here.
Oh. Orange?
When taking
I thought you were about to put taken.
an even root, the result will be plus or minus.
Hey, actually, that's a good question.
Okay.
Can we go to the calculator and I know you showed it to us one time.
Okay,
But-
let's stay on topic here. I'm recording, trying to get through this.
Taking
When taking the eventh root,
even.
the square root, the index is even 2. The 4th root, 4 is an even number. Because
Oh, so if it was 3, it wouldn't be plus or minus.
that's odd.
Yeah, so
Wait, but
if
how'd
it
you
was
get 3?
odd, it wouldn't be.
That's right.
Did you just divide
Yeah.
81 by 4?
So, no, What's your question?
That was gonna be the same.
Same thing, yeah. Yeah, if this number is odd, there's gonna be one answer. If this number's even, there's two. Because what's 3 times 3
9,
times 3
27.
times 3?
81.
What's negative 3 times negative 3 times negative 3
Negative 27.
times negative 3
Negative, oh.
No, positive.
positive 81? Okay?
Wait, but how'd you do that in your head though, like to get the 3?
Because we've had multiple problems in a row where we had 3 to the 4th power. If 3 to the 4th power is 81, then the 4th root of 81 better be 3 or negative 3. Okay? How do I get rid of a cube root?
Square it. No.
Cube it.
Cube it. Wasn't that a measurement in building the ark? A cubit. Okay, when you cube a cube root, that cancels, leaving with the x. What is 3 to the 3rd power?
It's
No.
27.
27. What is negative 3 to the 3rd power?
Negative.
Okay. And you have to check them both. Make sure when you're checking negative numbers, you put that negative 20 inside parentheses. Okay? So you actually want to do 27 to the 4/3 power. And what do you get?
81.
Okay? So that checks. But to check the negative 27, you better put it in parentheses. Negative 27 to the 4/3 power is
81.
also 81.
Could you possibly get one of them that worked and one of them that didn't?
As we're doing problems like this, it's possible that one works, both work, or neither one works.
Why though? If it has to be the same in order for it to be right, shouldn't it have to?
When you start working with square roots and cube roots and 4th roots and everything else, you might remember a term that was used a long time ago called extraneous. When solving problems, you have extraneous solution. Comes from the root word extra. Okay, so it's possible to have extraneous solutions where you do all your math right, and it happens a lot in absolute value problems. You do all of your work perfectly correct, and everything's good, but when you go to check it, it doesn't work. So always check. In this case, they both check, therefore x is either 27 or negative 27. We might also have to write that in set notation, negative 27, comma 27. Or maybe you write it as brace plus or minus 27, whatever. Pay attention to what the computer asks for when he's talking about answering questions. Okay. Next problem. We're going to talk about money. A long time ago, you probably saw the formula I equals PRT. Interest is equal to principal times rate times time. Where time is in years. And then later on, we kind of add to that. That is simple interest. A lot of times, interest is not simple. Simple interest, what was that?
I moved it.
Okay. Simple interest is just that. You get interest on that money. Compound interest is when you get interest on top of interest. Okay? So compound interest, the formula is A equals P times 1 plus R raised to the T power. So that money is compounded over and over and over and over again. Now, this formula is only good when it's compounded annually. How many times a year does annually happen? Once. Okay? If interest is compounded quarterly, how many times a year is it compounded? 4. Monthly. Weekly. Okay? So you have to pay attention to how many times a year is it compounded. So if it's not 1, you take the interest rate divided by the number of times it's compounded, and that's going to be raised to the, I don't know why this book does it this way, to the Tn power. I will not write it Tn. Okay, my alphabet N comes before T. So I'm always gonna write it NT. Okay. Suppose we have $1,000. We find an account that pays 4%. It doesn't exist. But anyway, suppose we did. It's compounded quarterly. How much money will we have in 10 years? Very simple problem. The formula for compounded interest is A equals, I think about A as after. How much money do you have after this is all taking place? P is the principal. That's how much you started with. Dell, you doing all right?
Yeah.
Okay. Times 1 plus the interest rate divided by the number of times a year that it's compounded. Raised to the number of times it's compounded a year times the number of years. Where's the 1,000 go?
The 1,000 go at P.
Okay, so we're looking for the after, right? 1 plus, what is our interest rate? 0.04 for 4%, 0.04. How many times a year? 4, compounded quarterly, so 4 times a year. Raised to the
10. Wait, 4.
4 times
10.
10 power. And that's just a matter of typing that in your calculator.
Yes.
Okay. And you get A is what? $1,488.86 or so.
Yep.
How much money did you start with?
$1,000.
$1,000. How much interest did you earn?
$1,488.
$488.86, which is question B. Question B says, how much interest did you earn? All right. So that was just the 1488.86 minus the 1,000 we started with, which is 488.86. We didn't have to do anything. The money was set in the bank for 10 years, and we made a whopping $48 a month, or a year. And a couple cents. Next problem. Becky must pay a lump sum of $6,000 in 5 years. This is actually a real true possible situation, a lump sum. Have y'all ever heard of the term a balloon payment? A balloon payment? A balloon would be a big payment at the end, that's what that means. So it's possible that maybe you buy a car, and maybe you finance the entire amount of the car, and you're gonna pay for that car in 60 monthly payments. And at the end of 60 months, the car is paid off, okay? You're done, you paid it off. There's other loans that you might be able to do. You might, I think some of the terms are ARM, or balloon payment. So you might buy the same car, but in order to get your payments lower, you do this situation, you make a balloon payment. So what happens is you make 60 equal payments. But when you get done making those 60 payments, you still don't own the car because you still owe $6,000. Okay? And that would be an opportunity that maybe at that point you wanted to finance that $6,000 separately. You could do that. Okay, but that's what this lump sum means. So Becky needs to pay the $6,000 in 5 years, which is another good thing because maybe she's got some money sitting around that she wants to put in some account, maybe invest it. I wouldn't put it in a savings account. You're not going to find 3.1%. Maybe she wants to invest some money, and then later on she'll take that money out and make that $6,000 payment, no problem. How much money would she have to deposit right now to have $6,000 in 5 years? It's the same formula. The amount she has afterward is equal to the beginning amount times 1 plus the rate divided by the number of times it's compounded a year raised to the NT power.
But this one we do the December one because it's annual. Isn't it?
No, because this is interest on top of interest, so it's compounded. What's after?
6,000.
That's what I want to end up with. 6,000 is equal to, how much do I start with? We don't know. So P. Times 1 plus 0.031 is the interest rate over
Over 5. Right?
One.
Or 1.
1 raised to the
1
1 times 5.
times 5.
So we have 6,000. I'm just going to simplify this sum here. P times, well, 0.031 divided by 1 is just 0.031. Plus 1 is 1.031 to the 5th power. I just have two things multiplied together here. So to get P by itself, I will divide both sides by this. So P equals 6,000 divided by 1.031 raised to the 5th power.
That is 5
$5,150
with 60 cents.
and 60 cents. So I put $5,100 in the bank. It's going to draw interest for 5 years, and it should be around $6,000 at the end of those 5 years. This is only part A, but we don't have time to go on. We will wrap up 4-2 on Monday.
Mr. McThrowey, are you planning on